Today we're going to go over a couple of different things. First, we're going to go over length of the longest substring without repeating characters, Leetcode question. And the way that you can solve this is the problem is you have this string and you want to get the length of the longest substring without repeating characters. So for this one, it would be 3 and it would be ABC, right? Because ABC has non-repeating characters. If we go to A, those are repeating. If we do A, B, C, B, A, B, the B's are repeating and the A's are repeating. And then C, B, B, A, B, C, B, B, those characters are also repeating. So find the length of the longest substring where we don't have repeating characters. So how do we go about doing this? So one of the ways that we can do this is by going through each of the letters. So for all letters in this string, for all characters in this string, going through each of them, creating first a map of the letter to its frequency. So when you go through each of the letters, create a map from the letter to its frequency. So you're going to start at A, and then while the values in that map are all one. So what does that mean? While all of the values in the map, while all of the values in the map are one, so that means that the frequency of each element is still one. So that means it's not repeating. There has not been a repetition thus far. So if A will be in this case, right? In this one example, A will be 1, B will be 1, C will be 1, and then as soon as you reach the other A, then A will be 2, suggesting that A has occurred twice in this substring up to this up to this far. And then so because all of the values are not 1 because A is 2, then we break out of this loop and then we update our maximum length. So we update our maximum length. Max length equals max of the current max length and the length that we're at. So in terms of ABCA, if we see that A, the length will be 3. So that's how we're able to solve this. And one of the keys of knowing how to do this problem is understanding the data structure of a map. So understanding that hey, we can store letter frequency, we can associate the frequency to the letter, and that's going to help us understand if a string is repeating or not. So that's something that we can learn from this. Another thing is this problem is very good at visualizing what steps you want to do to solve the problem. So what do I mean by that? So if we look at this string, one of the ways that you can visualize this is thinking about, hey, I want to go through every single character, right? I want to go through every single character, and then for each character, I almost want to go through the entire string again, but not as in O of n squared, but I want to go through the entire string again by having a map, such that I'm storing the letter frequency associations. And so that's going to help us determine if a substring is repeating or not. So that's one of the other things that we're able to learn from this. And then I guess a couple other things we'll go over is semi-structured. So we have unsupervised learning, we have supervised learning. We have unsupervised learning, supervised learning. So supervised learning is what we talked about. We have this label in our data set that we're trying to predict. So if it's like a regression model, we're trying to predict some target variable, whether this customer churned, whether it's the lifetime of this customer, whether we're predicting survival probabilities. There is some target value that we're trying to predict. Unsupervised, as we've explored earlier, is without label. You don't know what to predict, or you don't have a target to predict, but instead you're given a data set and you're trying to find some sort of pattern or trend, or is there some trend within the demographics? Is there some association or clustering that we can make from the different customer attributes? So it's extracting insights from unlabeled data that doesn't have a specific target variable that you're trying to predict. So obviously both are useful in a variety of different settings. Supervised is typically used when you're predicting like a regression model or a classification model, whether you're predicting if a tumor is benign or malignant, whether you're detecting if an email is spam or not. A classification, any type of classification, any type of regression model would be considered under supervised, and then unsupervised is where your typical clustering algorithms go. So your DB scan, PCA, I mean, PCA can also be used as a clustering algorithm. First, you reduce the dimensionality of your data set, and then you can do the clusterings using the PCA. And there's also k-means, which is a pretty common algorithm. So using these two techniques, clustering, and then as well as for unsupervised, the regression and classification are sort of the two main aspects when we think about machine learning. And then obviously there's also reinforcement learning, which is all about an agent learning from the environment. So an agent performs an action, it gets feedback from the environment. The environment provides a reward or a penalty depending on the action that the agent has taken. And then the agent is able to update the policy, which is the strategy it uses to generate the action. The agent updates the policy based upon the feedback that it's given from the environment. And so the entire goal of this is to maximize the future reward of the entire system. So we have unsupervised learning, we have supervised learning, and then we also have reinforcement learning. So these are the almost like three main core types of learning in machine learning. You can broadly characterize any type of machine learning algorithm into these three buckets. Now let's talk about like other side projects or more interesting projects that you may want to do. One is on the survival analysis. So one of the main things obviously in insurance is we were trying to predict how long a customer will retain or how many policies will drop off after a certain period of time. So what we have is we have this survival curve where we have this drop where we're illustrating the drop off of policies, right? So month index 10, which is at the beginning of the policy, when the policy first started, we may have, X number of policies, and then we can see some sort of decay. After the first month, only 90% of those are retaining. After the second month, only around 70% of those original 100 policies are retaining. So we can see some sort of decay. Now you can approximate this using either like a time series, where you're just using historical data, or there could be some other situational factors that are also going on that influence the decline in survival probabilities. So you can either use a time series model to model this. You can either use or you can use some other piece of information if you have information on market trends, or if you have information on certain demographics, customer demographics, they may also influence this survival curve. Perhaps certain demographics have, obviously a higher survival probability in certain months, and that again really depends. Sometimes depends on the geographic location slash other factors. So you can build out this entire machine learning model to predict that, or you can use like your simple whatever time series. But there's many different ways that you can approach this entire concept of survival analysis. So one of the projects associated with this is you can have like a JavaScript web app slash HTML. You can also do this in Flask with Python. You can have these different inputs where you input in, hey, here's the survival curve that currently have, like up till, let's say, starting from month index 12, negative 12 to like month index 12, and then now project out the rest of the 150 months based upon what you've seen so far, and then also some historical data. So that could be a project where you're inputting the historical data that you've already seen, and then the model. You can have many different models, time series models, ML models that you're running, and you can even have like a button that says, "Hey, run this model," and then it will give you the output. If it's just like a simple time series model, then it will show you, okay, it will show you like the time series trend for the 150 months. If it's like a simple ML model, then you will just be able to enter in the different attributes and then get the prediction on these many policies will be retained after X period of time. Another one is typically we also do loss modeling. So when we have so this is obviously when companies have large number of losses or large number of claims that they're working with, and we want to model those losses. And we typically do this through frequency and severity. So frequency is referring to how often those losses are occurring. So we typically bucket these into uh, different categories of losses. You can almost think of them as like different layers of losses. Like first layer would be like losses that don't occur as frequently. Second layer would be like moderate level of losses, and then the third one would be like losses that happen pretty frequently. And so there would be like some given range, let's say like a range from 0 to 100K and then 100K to 500K, and then anything above 500K would be considered like an extreme loss. So you can sort of group these. So one of the other things is like how can we develop these different groupings, right? How are we able to develop these different groupings? So one of the projects is you can enter in a data set that has all of the losses. So for example, we'll have like loss one was this, loss two was amount this, loss three amount this, whatever. And then you can see what would be an appropriate bucketing for those losses. And you can use many different statistical techniques to like give an output of, hey, these are the suggested buckets, depending on percentiles, median, range, mode. What you can use all of those statistical techniques to come up with certain ranges. And then with that, sort of a second layer to this is then you can also model. So one of the ways you can model frequencies is by using a Poisson distribution or like geometric or negative binomial, whatever distribution, uh, whatever discrete distribution you want. Because for frequency, you're typically thinking about like, hey, this event is likely to occur 1 in every 2 years, or this event is likely to occur 1 in every 4 years. You're trying to model that probability. So it's a discrete probability. So Poisson, negative geometric, you could have all of these different distributions and you can try to fit each of those distributions to the losses that you're getting. And then you can see which of those most accurately represent the data. And then you can output, hey, this distribution, you can even output visually, like how if you were to graph this distribution on these losses, how that would look. And then you can also like give it a metric or a score of the fit of the distribution on the data. So you can input the data through like a button or some sort of file uploading system, and then you can click submit, and then you can get a range, or another parameter could be what distributions you want, and then you can get the range. You can get all of the distributions fitted to the data, and then a metric on how well they have fit the data as well. So that's another pretty cool project. And then another aspect of this is frequency, and then another is severity. So we know how often the loss is occurring, but then when that loss does occur, how severe is that loss? So that will be more of a continuous distribution. So you can gamma or normal distribution, beta. There's so many more distributions that you can use to model the severity. And so this could, again, similar to the frequency, this could be like another UI where you can enter in the severity of the losses and then select, hey, I want to test out gamma, normal distribution, beta distribution, etc. And then it will give you the output, which would be the A visualization of the distribution on the data points. And then it will give you the metric of how well does this distribution fit the data. So using these two, we can model the losses that a client is facing. And one of the reasons why we want to do this is because in the future we're able to better predict if we have this model of distributions that goes along with the data that's highly related to the data, then in the future we can predict, hey, in X number of years, this is the amount of loss that would be incurring based upon the data that we have, based upon the distribution that we've modeled the data to. And so that's pretty it's a pretty cool project, and it's pretty fun. Another one, as I think we sort of talked about this, is on animations. So you can run DFS, BFS, any graph traversal algorithm on like a maze game. On if you're doing any sort of graph algorithm, you can essentially make anything into a graph. Right? You can make anything into a graph. So doing BFS, DFS on really any idea that you have, any concepts that you can turn into a graph representation form. And then you can have some inputs. You can create the graph. You can have the user create the graph and then find the shortest path or find the nearest, like then all of the closest neighbors or neighbors that are distance of n away. So those are some things that you can do with graphs and animations. Another thing is you can also do something just with data frame manipulation. So obviously this is a common thing when you're doing a lot of group bys and you're doing a lot of merges. Another thing is you can have two data frames. You can have like an input for one data frame and an input for another data frame. Do some sort of merge or concatenation between those two. Create a program for that. Another is when we have these algorithms, so like k-means or db-scan, a lot of the times we just take them for granted. Like we just have this code that we use. We might look it up, but a lot of times we just take it for granted. Can we implement k-means from scratch? And by from scratch, I mean creating and randomly initializing the centroids first, and then after you randomly initialize them, calculating the Euclidean distance from the points to the centroid, recalculating the centroid, and then stopping when the centroids don't change. So doing that from scratch in NumPy is really going to enhance your understanding of k-means and really any algorithm that you create from scratch. Um, if you create db-scan from scratch, that's going to enhance your understanding of db-scan as well. So and even PCA, right? So any of these algorithms, even like the more complex ones, they could be harder to implement. But once you like go through the math behind how they work and then implementing them, it's going to increase your understanding of how they work and its use case as well. So those are the main projects that we talked about, and I wanted to go over. And again, you can be more creative with this as well. Like you can create a UI with k-means. You can create a UI with PCA. Create a UI with all of these different algorithms. You can run all of these in the web app that you're developing. So there's a lot. Point is like there's a lot of different projects that you can do, and the main moral is really being creative with the types of projects that you're doing. Really, any idea that you can get, whether it's from a YouTube video, from an article you've read, from a thought you've had in mind, any concept, you can essentially turn that into a project, and you can create that project and display it. And so that's sort of how I think you can create a lot of fun in the content that you're learning, not just learning the content, but also doing something with it, making it in your own and internalizing it. And so doing these different projects is a way to do that. So that's pretty much all I wanted to cover. So we talked about this Leetcode question, length of longest substring without repeating characters. We talked about how the approach was to create a map from letter to frequency, and then whenever we see a repeating letter, the frequency would change to 2, and when it does change it to 2, because we're checking that while all the values in the map are 1, if it does change to 2, then we have our new length, and then we're able to update max length. So if it is the max length, it will be updated to max length. And then another thing, another side note to that is I saw that it didn't work for like some of the out of bounds cases. So I essentially added another character to the end of the string and it worked. So one of the other sort of lessons from this is you can make something work, but then you just need to tweak the input a little bit to make the entire code function. And so this is one of the things, this is one of the techniques I implemented here. We talked about unsupervised learning, supervised learning, reinforcement learning. Those are like the main three. There's also like semi-supervised learning, which is like a hybrid of unsupervised and supervised. But those are the three main. There's also NLP, main learning algorithms, buckets of learning algorithms in machine learning. Talked about survival analysis and some of the projects that would be fun. So that's all for this video. See you in the next one. Thanks.